It's another chance that God has given us an opportunity to meet and continue learning. We are still in the topic of DC machines, and today we shall be looking at types of generators, and one of the type of generators is a shunt wound generator. In the previous video, we looked at separately wounded uh, generator. We looked at the calculations on how to perform, and today we shall be looking at calculations involving shunt wound generator. So the learning outcome says by the end of the video, you should be able to perform calculations in shunt wound generator. Any calculations involving shunt wound generator, by the end of the video, you should be in a position to solve it. Let's look at example number 1. And our example says that a shunt generator supplies a 20 kilowatt load at 200 volts through cable of resistance 100 milliohms. If the field winding resistance RF is 50 ohms and the armature resistance, that is RA, is equals to 40 millivolts. Determine the terminal voltage. Part B, determine the EMF generated in the armature winding. So in a shunt wound generator, here there are some things that we shall be looking at. We have voltage known as terminal voltage, and we have the normal EMF that is generated at the armature winding that we looked at in the separately excited generator. Now, in this particular question, part A, when we are asked to look for the terminal voltage, we can see in that question we have power, whereby we have 20 kilowatts, that is our load, with 200 volts. In that particular case, we can look for current because we know that power is given by voltage times current. So we can look for the load current, and the load current will be given by power divided by this voltage here. So we shall have 20,000 watts divided by 200 volts. And when we divide this, we shall have our load current as 100 amperes. After getting the load current, the equation says that we have cables of resistance 100 milliohms. So this is the resistance. So in this load here, the current that is traveling in this direction is 100 amperes. But we shall have a voltage drop from this section here. This voltage here is 200, but we have a resistance which is 100 milliohms. So we shall have a voltage drop here, and this voltage drop here is what we are calling terminal voltage. So we shall have to look for voltage in this circuit here, and we shall use Ohm's law, whereby we know that voltage is given by current times resistance. So our current is 100 amperes, and our resistance is 100 times 10 raised to negative 3, which will be 10 volts. So the voltage drop here will be 10. So the total voltage in this direction, we shall have to add the load voltage plus the voltage drop for us to get the total voltage in this particular uh, point where we are calling it as terminal voltage. So our terminal voltage would be given by, which is V, would be given by 200 plus 10, which will total up to 240 volts. This will be our terminal voltage, the voltage at this direction. We know that in series circuit, for us to get the total voltage, we have to add all the voltage drops. So we have this voltage here and this one here. So when we add this one and this one, we shall have the particular voltage that will be measured in this direction. Are we together up to that point? Let's look for part B. The EMF generated in the armature winding. The EMF generated in the armature winding, sorry. Apology for that, sorry for that. And armature, the armature, that is the EMF generated at the armature winding. Here we have few things to work on before we get the EMF at that particular point. And the first thing is to calculate for the, let's look at this circuit here. In this circuit, we have the armature. This, we are looking for this voltage here, the voltage at this point. And we have this current. We have that current, which is armature current, and we have the field. We have the field current IF. So the first thing, when we look at the Kirchhoff's law, we know that that is a KCL, Kirchhoff's current law. We know that current leaving a junction is equals to the current entering the junction. Are you together? So this is a current that this current is entering, it is moving this direction, and this one is moving the other direction. So current I will be equal to IF plus IA. That is the armature current plus the field current. I love to post a video on Kirchhoff's current law and Kirchhoff's voltage law. We shall do that. I forget to teach on that section, but I'll upload it in the next video. So armature current will be given by IF, that is a field current plus the load current. If you look at this circuit here, we have seen that this current are leaving the junction. We have this that is going this direction, and we have this one that is going this direction. So this current here will be equal to this one plus this one. That is Kirchhoff's law. IA will be equal to I load current plus the field current. Okay, so for us to get the field current, we shall have to use not Kirchhoff, but Ohm's law, whereby we shall use the terminal voltage, which I've got as 210 volts, divided by the field resistance. And we have been told that the field resistance is 50 ohms. Therefore, IF will be equal to 210 volts divided by 50 ohms. When you take your calculator and key in 210 volts divided by 50, you shall get 4.2 amperes. So this will be our field current. Hence, our armature current will be equal to the field current plus load current. Therefore, our total armature current will be equal to 4.2 plus 100, which is equals to 104.2 amperes. This is our armature current. And from the previous equations, we had seen that the EMF is equal to V, that is the terminal voltage, plus armature current times resistance, armature resistance. Let me repeat. For a shunt wound generator, EMF is given by the terminal voltage plus the armature current multiplied by the armature resistance. I hope that is clear. Therefore, we shall have this is a repetition. This the same as this. So we shall have our V is 210 plus armature current is 104.2 times our armature resistance is 40 milliohms. So shall be 40 multiplied by 10 raised to negative 3. When you work on this bracket here, you shall get 104 point 100 104.2 times 40 times 10 raised to negative 3, you will get 4.168 volts. So this voltage we will have to add with this voltage here, and our total EMF will be 214.17 volts. 214 and 204, 217, 214.17 volts. Remember, I said my class is full of assignments. It's learned, or it's learner centered, whereby you have to participate. So we have exercise 1 for this video, whereby you shall it's requiring you to explain the meaning of a shunt wound generator. Remember, in my video 1 on DC generators, I uploaded a chart whereby it has classification of a DC generator. So shunt wound is a type of a DC generator. Now, the question is asking you to explain the meaning of a shunt wound generator. At your free time, work on that assignment. Example 2. A shunt wound generator supplies 50 kilowatts load at 400 volts through cable of resistance 0.2 ohms. If the field winding resistor is 50 ohms and the armature resistor is 0.05 ohms, determine the terminal voltage. Part B, the EMF in the armature winding. This question is more of the same as the previous one. What we have just done is changing the number of values. For the previous question, we had seen that the load is 20 kilowatts, but for this case here, we can see that the load is 50 kilowatts, and the voltage in the previous one was 200, and this one is 400. The reason as to why I'm bringing a similar example is to just emphasize on the previous one so that you can understand better. Let's look at the solution. We have been asked to look for the terminal voltage. So part number 1, or the first exercise, or the first thing to do, is to ensure that we look for the load current I, and we say that power is given by voltage times resistance. Voltage times current, sorry, voltage times current. But for this case, we have power already. So for us to get current, we have to make I the subject of the formula, whereby I will be equal to P, which is power, divided by V, which is volts. In our case, our load is 50 watts, 50 kilowatts. Kilo means 1,000. So we shall have 50 times 1,000, which is 50,000 watts, divided by 400 volts. If you take your calculator and key in 50,000 divided by 400 volts, you shall get your current to be 125 amperes. You can confirm the total load current will be 125 amperes. Now, as we did in the previous case whereby we had to look for this terminal voltage here, we have a terminal voltage, we have a voltage in this case. So we have to add the load voltage that we have been given, which is 400, and we have to look for the voltage drop in this section. So voltage drop in the cable through the resistor. Using Ohm's law, we know that voltage is given by current times resistance. And our current is 125 amperes, and our resistance is zero point 0.2 ohms. It is here, it is 0.2 ohms. So our voltage will be 125 times 0.2. If you multiply 125 times 0.2, 0.2, you shall get 25 volts. So for us to get this voltage in this section here, you have to add this voltage here and this voltage here for us to get the total voltage here, which we are calling it the terminal voltage. So terminal voltage V will be given by the load voltage plus the voltage drop V1. Hence, the total voltage at that point is 425 volts. This equals to our terminal voltage. Let's look at part B. Part B is asking us to look for the generated EMF in the armature winding. Remember, we cannot go straight and look for the armature, the generated EMF without looking for the IF. And we said IF is the field current. And as you can see in the first diagram here, this is our field current here. The current that is flowing through the R resistance, RF, or the field resistor. Therefore, once we get IF and we have I, it will be easier for us to look for IA because this is the current that is entering, and we have IF leaving the junction and I also leaving the junction using the Kirchhoff's law KCL, whereby we know that the current entering in a junction is equal to the sum of the current leaving the junction. So IA will be equal to load current plus field current. I know that is clear now. And we know that the armature or the EMF generated by the armature winding will be given by the terminal voltage plus armature current times the armature resistance which will give us the armature voltage. And once we add those two, we shall have the total EMF generated in that section. Let's continue and see. So IF will be equal to the terminal voltage divided by RF, the field resistance, which we were told is 50. So if you take your calculator, that is 425 divided by 50, you shall get 8.5 amperes. So we know that using the Kirchhoff's law, that is KCL, when you look for the IA, will be equal to the total current that is leaving the junction, that is IF plus I. Therefore, we shall have 8.5 plus 125, and our total current will be 133.5 amperes. I believe that is correct. And we are together up to that point. So the armature, or not the armature, but the EMF generated E will be equal to the terminal voltage plus the armature voltage. and the armature voltage will be equal to IA multiplied by RA, and our RA is 0.05 and our IA is equals to 133.5. So if you take 133.5 times 0.05, we shall get 6.675 volts. So once you add these two, that is 425 plus answer, 425 plus answer, we shall get 431.675 volts. So we can round off to the next decimal place, and our total EMF generated at that point will be 431.68 volts. And remember, my class cannot end without an assignment, and I have an assignment for you here. And the assignment says a shunt generator supplies a 30 kilowatt load at 400 volts through cable resistance of 0.02 ohms. If the field resistance is 50 ohms and the armature resistance is 0.08 ohms, determine the terminal voltage and the EMF generated in the armature winding. That is all for today. Do more exercises. If you can change this, just another version of the same, the first example, just that we are just uh, dealing or changing the values. So you can change the values in two or more exercises and work on it. Let's meet in the next video. Thank you for watching.